This is Gustavo Dziewczapolski, Scientific Director of CMD. I want to share with the community my impressions about the meeting which has finished in Paris, France, specifically dedicated to the progress, new knowledge and new ideas to find treatments and cures for LMNA-CMD subtype. We spent 2 intense days in the auditorium at the Institute of Myology, listening to the world's most accomplished scientists and clinicians in the field of laminopathies and engaging with them in very constructive discussions. We heard about the progress in the retrospective natural history study of the LCMD pathophysiology, a fundamental piece of data for designing future therapeutics. We heard about the advances in gene therapy and the use of the latest technologies in the gene editing, for example, to correct mutated genes and how are they being applied in research labs to make them ready to translation in human medicine. We hear about managing cardiac difficulties and the amazing work done at the hospital in Barcelona, where they are implanting monitor devices to register 24/7 data from LCMD children's hearts and image analysis with 3D reconstructions. We also learn about the positive results with an experimental drug directed to slow down the cardiac pathology and the potential development as a real drug to treat affected individuals. This is only a glimpse about the conference, but there is something else a little difficult to express with words, which is the power generated by the interactions between the expert scientists and clinicians and the representatives of affected individuals. There is no doubt for me on the importance of this type of meetings, which are power generators to arrive to those who needed treatments for our community. Okay, this is it for now. Looking forward to further reports on the progress of the projects discussed during the LMNA-CMD meeting. We all need to help keep the momentum strong. We need to pass the voice that all these exciting ideas need funds to develop its potential. So I invite everybody to make the donation you can to support the research. Thanks for listening.
Hello, this is Jesse Scanlan, father of G.R. Scanlan, who within the last year was diagnosed with a LMNA disorder. I am outside of the Institute of Myology here in Paris, France for the 3rd annual LMNA Symposium. I am very excited to be here and after day 1, listen to all the things that these great doctors, researchers, scientists have been working on for our community. It's overwhelming how exciting the opportunities are, and great to see how far they've come just in the past year. So looking forward to more updates today, and once again, super excited about the opportunity.
Good afternoon, everyone. Actually, good morning and good evening for some of you from different longitudes in the world. I am Gustavo Dziewczapolski, the new Scientific Director of CMD, and it's my pleasure to give you an update today about the outcomes of the 3rd LMNA Consortium meeting held at the end of October in Paris. And I will be joined by community participants at that meeting, Lindsey Armstrong from Scotland and Jesse Scanlan from Minnesota. They will share their impressions with us about the meeting from the community perspective. This meeting was possible thanks to the sponsorship and organization by CMD, through a generous award we received from the Patient-Centered Outcomes Research Institute, PCORI, and it was co-funded by Fundación Andrés Marcio, Niños contra la Laminopatía, a very active organization from Spain. It was hosted at the Institut de Myologie by Dr. Giselle Bon. She and her research team were the first in finding a mutation back in 1999 on the LMNA gene responsible for CMDs. We spent 2 intense days in the auditorium at the Institut de Myologie, learning and interacting with the world's most accomplished scientists and clinicians in the field of laminopathies and CMDs. I would like to start this webinar with a very brief introduction to CMDs in general and LMNA CMDs in particular, and then share with you the most relevant scientific advances presented at the meeting in Paris. Then we will listen the impressions of family members of affected individuals which attended the meeting, and finally we will open the discussion to all the participants of this webinar. So congenital muscular dystrophies are considered those cases where hypotonia or weakness are present at birth or early childhood. CMDs primarily affect voluntary muscles. In these cases, the protocol to achieve accurate diagnosis indicates performing a muscle biopsy. And the presence of dystrophic morphology usually confirms a CMD, and then clinicians work up the case by studying particular features of the muscle morphology and presence or absence of specific proteins, leading to a CMD subtype diagnosis. Then the ultimate confirmation of the subtype of CMD an affected individual has is a positive result in genetic testing when doctors find a mutated gene. To understand better the origin of the heterogeneity of congenital muscular dystrophies, let me guide you through these cartoons. Here we have a transversal section of a muscle. We see it is composed of bundles of muscle fibers. Each one is a muscle cell here, wrapped by a membrane called perimysium. Each of these bundles is called a fascicle, and various fascicles wrapped together by another membrane called epimysium constitutes a muscle. All these wrapping membranes are interconnected and end up forming the tendons, which will insert the muscle to the bone. So if we take a biopsy and we zoom in, we will see the morphology and organization of each individual cell in the fascicles of a muscle. And if we zoom in again here to look at individual cells, we'll see the molecular machinery of the muscle fiber. Each muscle cell has a cellular membrane here called sarcolemma, which separates the extracellular space to the intracellular space. Here in the extracellular space, we have the extracellular matrix, very important for support. Here, the extracellular matrix, very important for support of each cell and interconnecting the muscle cell all together, facilitating the functionality of the muscle as a whole. And inside the cell, we have the space called the sarcoplasm, where the organelles of the cell reside. And today, we will be particularly focused here on this organelle called the nucleus, the place where the genetic material of the cell is located. why did I brought you all the way to the molecular machinery at the cellular level of the muscle? Because the classification of the different subtypes of CMDs is mostly based on the location of the protein affected by the gene mutation. So, for example, defective proteins in the extracellular matrix here provoke particular subtypes of CMDs like collagen 6 or LAMA2. Defective proteins on the cell membrane, these groups or this group, the most important protein called alpha-dystroglycan, or enzymes right here in the interior of the cell, which modify the glycosylation state of the dystroglycan, these sugar decorations here that are very important for the function of the muscle, can cause dystroglycanopathies or secondary dystroglycanopathies. Then defective intracellular enzymes lead to other subtypes of CMD. For example, one of the rarest CMDs known as CEPN1, or as I mentioned before, can lead to secondary dystroglycanopathies. Finally, our star today, deficits of errors in the nuclear proteins called lamin A and C. Different mutations here in this gene that has the instruction to build two proteins, lamin A and lamin C, provoke these proteins to be faulty. And both protein A and C constitute a mesh located here in the inner side of the nuclear envelope. It has a distinctive inheritance pattern. Most CMDs are recessive mutations, meaning that the individual affected needs to have the two copies of the gene mutated. For LCMD, the inheritance pattern is dominant, requiring a mutation in only one copy of a gene to produce symptoms. Dominant mutations are most of the times de novo mutations, meaning not inherited from the parents. These are usually spontaneous mutations. The potential roles of lamins A and C are maintaining the nuclear envelope structure, help maintain the chromatin organization, help in DNA replication and RNA transcription. And as most of the audience know, much better than me actually, these genetic mistakes cause weakness within first year, particularly in the body trunk and neck, rigid spine, curved feet, especially respiratory involvement and cardiac rhythm abnormalities. So all this information I just shown to you has been crafted by groups of dedicated scientists and clinicians which were discovering piece by piece and building this puzzle. And they are constantly discovering new pieces and trying to fit these new discovered pieces in that giant puzzle, which is the biological process underlying LCMD pathology. Definitely we are in the right path, but there is no cure yet for LMNA-CMD, nor for the other CMD subtypes. And here it comes one of the crucial roles played by CureCMD and Fundación Andrés Marcio in fostering research and interaction between scientists, clinicians, and affected families. Financing this type of meetings is critical to achieve clinical trial readiness. In other words, it's critical to plan, find, design, and implement treatments. So let me now walk you through a summary of the scientific advances presented at the meeting. I should mention that we have signed confidentiality agreement, so I cannot go into very details, so I will give you a general view of the studies presented at the meeting. We can start by talking about the LMNA retrospective natural history study led by Dr. Susana Quijano-Roy, Ivana Dabash, and Giselle Bon in France, and Dr. Karsten Bonnemann here at the NIH. This study is currently under statistical analysis to identify at what age different complications arise, most importantly breathing issues and heart issues. They are working with data files from 168 patients from 23 different centers. And we expect a manuscript ready by next annual meeting that we are planning now to be at the end of October 2017. Why this is retrospective natural history study is so important, because knowledge of the natural history of the disease is an essential element in the scientific foundation of any clinical development program, especially in rare diseases. And information about the disease natural history can aid in clinical trial design, identifying study endpoints, identify biomarkers, and lead to faster and better trials. Based on that retrospective natural history study, we are already planning a prospective natural history study. There is an ongoing exchange of ideas by email now on how to define different subpopulation studies for different objectives. For example, according to ambulation status and how this correlates with cardiac, respiratory, or contracture complications. Moreover, trying to decide which muscles should be monitored, inclusion of nutritional analysis, types of functional scales, etc. There is also plans to do a prospective study for patients under steroid treatment by Drs. Susana Quijano-Roy, Ivana Dabash, Soledad Monjes, and Andres Nascimento. They are currently conducting a retrospective study evaluating data of 27 patients already under steroid treatment, and this analysis will set the basis for a systematic prospective study, and there is a manuscript under preparation. Now let's move to the LMNA prospective heart study led by Dr. Georgia Zarzuela-Brugada in Barcelona, Spain. This is an ongoing study with 18 patients currently enrolled and on the study already implanted with the device. This is a three-step study, an advanced echocardiogram, an electrophysiologic study, and implantation of a Medtronic link monitor. This is a monitor that has a battery for 3 years, and it will show constant online data. And the aim of this study is to find predictors of the arrhythmias. And they are looking to enroll at least 50 patients in total or more, ages between 1 and 21 years. During the meeting and after, we already started conversations about the possibility to set up a second site here in the US to follow this protocol upon publication of the results. And there is also some plans to do something like a travel clinic for the group of Georgia Zarzuela-Brugada to travel around the world showing the protocol if the results are successful. And In parallel to the already ongoing study, as I just showed you from Georgia Brugada, there is work at the labs. We have the group of Antoine Mouchir there in Institute of Immunology, doing a prospective heart study in mouse models of the disease. Here we have one of these animals that it was he received a gene with the human mutation, and we can see compare the mutated mouse with the normal mouse, the wild-type mouse, that is an animal with presenting pathology similar to the LMNA in humans. And this is a very good model for the cardiac studies, because this mouse, if you compare the wild type here with the mutated mice, all the parameters for cardiac contraction, and they look really sick in the mutated mice, and you can see here the whole heart. The LMNA mice has dilated heart. Here is a transversal cut of that heart. We can see that the ventricles, the atria and ventricles are dilated. And here there is a picture showing a big amount of fibrosis in the heart tissue of these mice. This is at 6 months old. What Antoine Mouchir was studying in the lab was at earlier ages, before the full pathology is shown, and he find early disruption of the intercalated discs and improvement by a drug effective in other cardiac pathologies. The intercalated discs are zones of the heart muscle cell that connect with each other. So this is a very important piece in the cell to maintain a synchrony when there is a contraction of the heart. They also found that the LMNA mutation disrupts the ratio between filamentous and globular states of actin. Actin is one of the filaments necessary for contraction, and the group of Antoine Mouchir are dissecting the molecular mechanisms regulating this ratio, and this study could uncover targets for drug intervention. One of the targets already uncovered is an elevated level of protein kinase. And based on that studies in mice, there is a project to do a preclinical study with a protein kinase inhibitor. This is led by Dr. Uday Khair, the co-founder of a small company called LMNA, and Dr. Howard Worman and Dr. Antoine Mouchir are involved in this study. Let me tell you that Dr. Howard Worman is like the father of LMNA field. He was the first scientist describing this gene back in 1993. The LMNA compound they tested in the mice, and it reverted the cardiac pathology in the mouse model, increased overall survival, reduced cardiac fibrosis, and improved ventricular function. Fundación Andrés Marcio is funding LMNA to complete the preclinical studies needed before moving into clinical trials. Now let's move to another type of research in the labs that we call disease in a dish. What it means is that you can take somatic cells, for example, skin cells, out of a person, in this case out of a patient with a mutation, for example, and now in the lab you can, with a cocktail of enzymes, you can reprogram these cells and make these cells to become like stem cells. It's called iPS cell because the I is induced pluripotent stem cells. So this pluripotency, you can do expansion of these cell populations, and then you can differentiate with different factors in all the different tissue cells of a human body. For example, neurons, bone cells, or in our case, muscles or cardiac muscles. And then it can be used for transplant. You can correct, actually you can correct before differentiation, you can correct with gene therapy these cells, and you could try to transplant back into the same patient where you take the original cell. Or what is more used now these days is for drug screening, and this is what Dr. Ann Bang in San Diego is doing. She had optimized and established both skeletal and cardiac muscle cells in a dish out of 2 LMNA patients with different mutations. So this is also great because any drug that you test, if you have 2 different mutations, you will see if it's the effect of the drug depends on the mutation, or is an effect, a generalized effect for different LMNA mutations. So she's now optimizing the assays to start the drug screening. It took a long time for her to get these cells in a very in a good health. It depends on the substrate where you plate these cells, and she found the best conditions. So she's ready to do the drug screening. Now the last piece of science that I want to share with you is the gene therapy study by Dr. Giselle Bon there in Paris. She was doing gene therapy already for many years with some success and some pitfalls, and now they are they have designed a new gene therapy study based on what they knew with the previous studies, with 2 different strategies. One that is gene inhibition therapy, because as I mentioned before, the LMNA case, you have one gene that is a faulty gene, but the other gene is normal. So one possibility is to inhibit, if this is the faulty gene, you can, using RNA inhibitors, you can try to block this faulty gene, and then you will have a cell functioning probably normally, but it will have only one copy of the good gene and the bad gene inhibited. But maybe we need to have the 2 copies of the gene for a good functionality of the cell. So the other approach is to try gene augmentation therapy. So they will try to inject the functioning gene and get a cell with 2 copies of the good gene and the bad copy inhibited. And they are screening all the inhibitors right now, and they have found, I think, 3 out of 20 that work very well in cells, so they will start as soon as possible to try this technology in mice. And the last thing I want to tell you is that there is a group of in Spain, but led by Dr. Ignacio Pérez de Castro, who returned to Spain and started a lab, and he's going to do gene editing using CRISPR-Cas9 techniques, and he will start soon. So in conclusion, current research in LCMD is in a good track to achieve clinical trial readiness, I think. The completion of these projects and recruit of new research and technology need funds, as all of you know, but it's good to remember. And the CMD community, our institution, CureCMD, and our partners, Fundación Andrés Marcio, Bit for Life, and a few other organizations, we need to keep engaged and engage more people for this cause, because a cure is among us. Okay, so that's the end of my presentation. I just want to thank you guys having me talk to you. I hope that this was helpful. Now I would like to pass the mic to the family members that attended the meeting for them to share with us their views about it and any comments they want to expose. So Jesse?
Yeah, absolutely. Thanks for your presentation, Gustavo. I think definitely a good synopsis of what we went through. Definitely getting a feeling for the research team that was there, simply amazing. I mean, so fortunate I think we are as a community to have such a diverse group of researchers, doctors, and scientists working towards our cause. And we couldn't have a better group of people and a more concerned group of people or a smarter group of people. And that was provided a lot of hope, I know, to myself and to the other families that were there. So that was, just in general, the feeling was one of a lot of hope, I thought. And, as we got into the details, there were, of course, a lot of, technology and medical things that we were getting into. And I know many families like myself, we're almost, in a sense, doctors of our children or doctors of ourselves for those who have the diseases. And so you could kind of fit in and understand the conversations that were happening. And as a part of that, you talked about the natural history. And, I know my family, we've always thought it was important to make sure that best data was out there. But then to see how the researchers and clinicians were actually using that data to make decisions on clinical trials and what to do next, I just thought, it was fortunate just that we make sure our CMD registers up to date and those things. I never realized fully the importance or potential importance of those registries and working with our own personal care attendants and staff to make sure we had the most up-to-date and current information and best information out there, because that data is and can be used and for some pretty amazing things. Those teams are moving, I would say, comparison to things that were happening many years ago, things are moving fast. So having the right data and good data out there, I can see is going to be pretty important. So, personally I'm working with my son to make sure that we do have that best information out there. The second thing that really stuck out to me was the cardiac care piece that you covered, and they really emphasized how the standard of care is changing because they're understanding that much more. And I know a lot of us have experience with doctors and changing care, and one of the things we talked about is changing a standard of care. Of course, a note will come out or something might come out, and but getting a whole generation of doctors to change a method, it's going to require family participation to advocate for a new way to do things and a new way to look at things. So I'm very keen on when that information gets published and more is shared with the community, what we can do as active members to help spread that word so everybody is getting the best standard of care. And personally, we're able to meet with my son's cardiologist. We got a meeting coming up here, and we're going to start the conversation because I think abnormality we're hearing is definitely an abnormality, and today we've taken a wait-and-see approach, and I think with the things they're finding now, it's pretty dangerous. And I look forward to the information that they have, coming forward in the future for those who, the younger patients especially. So, and then lastly, just the clinical trials. It's so cool to see all the different efforts that they've put in. To get to the place where they were able to study on animals and having conversations about putting it to human use trials. There was a day when my son had, very few tests to figure out what he had, and to hear that they're going into trials with things, even on animals, that's pretty impressive in this day and age. So, again, a lot of hope in that, and, overall general excitement around that. And I feel empowered to go out and speak with friends and family and get them involved and engaged, like Gustavo was, his call to action. So, I felt the call to action, and look forward to generating more awareness and hopefully more funds.
Great, Jesse. Thank you for your comments.
Hi, this is Lindsey. Can you hear me?
Oh, Lindsey. Hi.
Hi. I think what Jesse said summed up beautifully my impressions of the meeting. I think it was a real honor to be there. And I think, I agree with everything that Jesse said, basically, but just to sort of summarize it for me, I think just to know that there's so many talented, intelligent, dedicated people working on this disease is just incredible. We're a very small disease, a very small community, but I really think we've got some world-leading scientists and clinicians on our case, which is just incredible. And, to be in the room, be in their presence for 2 days, listening to them, talk incredibly passionately about, the disease that's affecting our kids was, it was really empowering, and it was really positive. And I think also being, there was a few parents there, and I think being in the presence of parents who, who also feel very passionately about that there is a hope and there's a lot that can be done for our kids was, just really helped. And I think, maybe some families feel that progress is slow, and I guess it does feel slow, being a mother of a little girl who's got the disease. But I think these guys are doing everything they can do. I really truly believe they're doing everything they can do, and I think their dedication is going to get us there. And I think it's really positive that we're having such a regular set of meetings, and everybody's from around the world is contributing to them. So I think everything I took away was just really positive, really good, and just great honor to be amongst it all.
Great, thanks. And yes, following on your comments, this kind of meetings also is a very fertile ground for to start collaborations, and already we saw in my presentation that many of different scientists from different labs, different parts of the world working together, sharing data, sharing patients, sharing results, and already after the meeting, for example, the group in France is going to use some of the cells that Anne Bang in San Diego was generating, so using the same protocol that she spent like a year optimizing it. So now it's optimized, and it will be much faster for the French group now to work with those cells. And yeah, this is this kind of meetings are extremely important to bring the people together and start collaborations.